In this video, I will show you how a full-bridge inverter works. So the full-bridge inverter basically takes in a DC voltage, which here is Vin, and then generates an output voltage. Now it generates the output voltage by controlling the two legs that it has, where we have leg 1 and then leg 2. So it controls the modulation voltages between the switches in the leg of each to generate the output voltage. Because if we look at the equation for the output voltage, you can see that it is equal to this modulation voltage minus this modulation voltage. So if we just write that up, we have VO is equal to VM1 minus VM2. And then we can try to find what VM1 and VM2 is. So you can see that the switches, that the legs are identical. So if we first find for VM1, it would be quite similar to what we get for VM2. So then we can first find for VM1, and then afterwards find for VM2. So if we look at the switches here, so we have a gate signal called S1. And then this overline for S1 means that we invert the signal. Now, let's say that S1 is equal to 1. This means that the upper MOSFET is closed, which means that there is current flowing through the MOSFET. And when there is current flowing through a MOSFET, the voltage over the MOSFET is almost 0. So this means that this voltage is equal to this voltage. So we have that VM1 is in this case equal to the input voltage. And now let's say that S1 is equal to 0. Then we have that this MOSFET here is closed, so no current flowing through that one. But this MOSFET is open, so the current will flow through here. So therefore, this voltage would be equal to this voltage. Now this is the reference voltage that we have here, so it is equal to 0. So VM1 is equal to 0 volts. Now this here can be written as a single equation. So we can write it as VM1 is equal to the gate signal multiplied with Vin. You can see that this is equivalent to these equations that we just found. And then we can do the same for the other leg. So VM2, now we just replace the gate signal with S2 instead. So we get is equal to S2 times Vin. So now we can actually insert it into the equation for the output voltage. So then we get that the output voltage is equal to S1 minus S2 and then multiplied by the input voltage. So now we're just taking out the input voltage. Now I just clear the page again. So we still have this equation here for the output voltage. And you can see that there are not many possibilities for the output voltage because these two gate signals can either be 0 or 1. And actually, there are only 3 combinations for the output voltage. And we can write that up now. So the first case is when S1 is 1 and S2 is 0. So S1 equals 1 and then S2 equals 0. You can see that in this case we have 1 minus 0 multiplied with the input voltage. So this will just be the input voltage. And then another case is when S1 is equal to S2. In this case, this here will be 0, so the output voltage will also be 0. And then in the last case, we have that S1 is equal to 0, while S2 equals 1. So then this would be minus 1, so we have that the output voltage is minus the input voltage. So you can see now that by controlling S1 and S2, we can switch between these three different voltages that output voltage could be. Now you might say that, but this is never going to be sinusoidal. But actually, we can get a sinusoidal signal on average if we switch fast enough. So you can see that the blue voltage here is the output voltage, while the orange one is the average of this output voltage. So if you, for example, add a filter on the output here, you can take the average of this output voltage to get a sinusoidal signal. And you can see that this is how the gate signals switches. Now, in order to determine S1 and S2, you need to know how a PWM works. And you also need to pick a PWM strategy, for example, a bipolar PWM or a unipolar PWM or a different PWM that I also explain in this document here. Now, this document also contains some Python plots, so you can test out how the different strategies works. Now, if you're interested in this document where I explain 3 different PWM strategies and also compare the different PWM strategies with each other with pros and cons, then you can just click the link in the description.